So we're going to start with a little review / revisit of Riemann sums. So I have a function, f of x is equal to e to the x, and I'm finding the area under the curve from 0 to 4. So let's say starting off here, I'm going to use a left Riemann sum with 2 subintervals. Okay, that's not going to be a very good approximation, but it's going to look something like that. And so the width of my rectangles would be what? 2. Okay, and so then my height would be, since it's a left Riemann sum, I'm going to take the x value of 0 and plug it into my function, right? So I would have e to the 0. And then I would take my next value of 2 and plug that into my function. So I would have this. Okay, everybody follow me there? No problems? All right, well, let's do another example here. Let's say I've got a left Riemann sum, but this time I'm going to have 4 subintervals. Okay, so sketching a quick little graph, it would look like something like that. And so what's the width of each of my rectangles? The base, excuse me, the height would be 1. And then it's a left Riemann sum. So I would plug in 0. So that would give me e to the 0. And then the next one would be e to the first. Correct. And then the next one would be e to the second. And the last one would be e to the third. Right. And notice I don't use the last value of 4 because this is a left Riemann sum. And on the left Riemann sum, I'm not using the last value there. Okay. So we okay with this right here? All good? Okay, well, how about we do this? Let's do a right Riemann sum this time, and with 8 subintervals. Okay, so what's the width now of each one? Okay, I'm gonna write it as a fraction of 1/2. And now careful here. Since it's a right Riemann sum, I'm going to not use the first value, right? So what goes right here? What's the first one? It would be e to the 1/2, right? Not 0. And then I've got plus e to the, what goes next? E to the first. Plus e to the 3/2. Plus, let's skip all the way to the end. I would have e to the what? E to the, what's my last value?
3.
Why? It is e to the 4th. Why is it e to the 4th? It's a right Riemann sum, so I've got to include the last value there. All right. We good with that? Let's do one more of these. How about we do a left Riemann sum? How about we use 40 this time? Okay. So what is the width of each of my rectangles? 1/10. Everybody see that? It's going from 0 to 4, and I have 40 rectangles. So each of them has a width of 1/10. And my first value would be e to the 0. So left Riemann sum. And the next one would be e to the 1/10 plus the next one would be e to the 2/10. And then the next one would be e to the 3/10. And let's skip all the way to the end. The last one is going to be e to the what? 39/10. Right? We all good with that? All right. Well, the reason I did that, I'm progressing here. I'm increasing my number of rectangles, and when I do that, I get a better estimation, right? I got 2 and 4 and then 8 and then 40. Well, that leads us to this. What if we have an infinite number of rectangles? Well, let's see if we can spell, first of all. All right, so an infinite number of rectangles would give us an exact area. Falls up. So let me just write down what the notation here means. Okay, so the A here is the lower limit. B here is the upper limit. The f of x here, if I'm doing a Riemann sum, is going to give the height of my rectangle, the y value. And the dx here would give me the base of my rectangle. It's the change in x. So if I wanted to find, going back to this problem here, if I wanted to find the exact area under the curve from 0 to 4, I would write it like this. I have the integral. My lower bound is 0. My upper bound is 4. My function here is e to the x. And this is with respect to x. Okay, so I have this new symbol. We say it's an integral. I have an upper bound and a lower bound. I have a function that's giving me the height of my rectangles, and the dx is telling me that this is with respect to x. Okay, so just to be clear, let's go to the next page and fill in the blanks. The integral from a to b of f of x dx means, what am I finding when I integrate? It is the area under the curve. And when I say area under the curve, what I mean really is between the x-axis and the function. It's the area between the function and the x-axis. And I have bounds telling me from which point I'm going to. So this goes from x is equal to a to x is equal to b. And so here's the connection that you need to make. This new symbol, the integral, means that I'm finding the area under the curve. And when I say that, I mean between the function and the x-axis from this point A to this point B. And believe it or not, this has enormous applications. In math, obviously, but also in physics and chemistry and engineering and biology, just as I can't overstate the importance of this application. And it all goes back to this. Okay, so a graphical representation, we have the integral from 0 to 3 of x squared dx. What am I finding here? Well, I'm finding the area under the curve. From what to what? From 0 to 3. So it's between the function and the x-axis. So let me shade in here a little bit. So just to be clear, when I have this symbol, the integral from 0 to 3 of x squared dx, I'm finding the area of this region, and I would end up with an exact numerical answer for that, which gives me not an approximation like a Riemann sum or a trapezoidal rule, but the exact area under the curve. So let me pause right there for just a second before we go on. Any questions over anything that we've done so far? We all good? So let's look at an example. We have an FRQ from 2009. This is question number 5. It is non-calculator. It says, let f be a function that is twice differentiable for all real numbers. The table above gives values of f for selected points in the closed interval for x between 2 and 13. Part A, estimate f prime of 4. Show the work that leads to your answer. This is a gimme question. College Board is giving away points because all I have to do is find the derivative. And the derivative is the slope. At what point? 4. Not a trick question, right? So I need to find the slope at 4. Which 2 points am I going to use? Oh, how about 3 and 5, because 4 is in between them. Okay, so when I find the slope, it's the change in y divided by the change in x. That's going to be equivalent to f prime of 4. So I need to find y2 minus y1 over x2 minus x1. So that gives me -2 minus 4 over 5 minus 3, which is -6 over 2. So I have a slope of -3. Okay. No problems there. Pretty straightforward. Part B, evaluate the integral from 2 to 13 of 3 minus 5 times f prime of x dx. Ooh, a preview of coming attractions, which we are not going to do right now. But here's why this is here. Here's the connection that we need to make, okay? This says use a left Riemann sum with sub-intervals indicated by the data in the table to approximate the integral from 2 to 13 of f of x dx and show the work that leads to your answer. Okay, so here's the connection. The Riemann sums and the trapezoidal rule are approximations of the definite integral here, which will give us the exact area. All right, so they want me to use a left Riemann sum using the data that they give me in the table to approximate this, the integral from 2 to 13 of f of x dx. Okay, so when I'm using a left Riemann sum, I do not use the, is it the first or the last? It's the last one. So I want to mark that out. And then I'm going to find the areas of my rectangles. So the first rectangle, the base goes from 2 to 3. So I have a width of 1. And my height would be the left value here, which is also 1. So that's my first rectangle. My second rectangle goes from 3 to 5. So my width is 2. And my height is 4. Next rectangle, my width goes from 5 to 8, so has a width of 3. My height is -2. And then the last one, it goes from 8 to 13. So it's got a width of 5 and a height of 3. And I'm going to go ahead and stop right there because all that's left is arithmetic. And especially if I'm in the jungle and don't have a calculator, I could have an issue with adding and multiplying there. So I got it. It's right. Let's stop. Okay. And so this Riemann sum, this left Riemann sum approximation is an estimation of what the actual area under the curve of my function is from 2 to 13. That's the connection that I want you to make. Okay. So questions on that? Well, let's look at a multiple choice question here then. The expression here is a Riemann sum approximation for which one? Okay, so let me just guide you through the thought process that we should go through in order to work this, all right? So first, this is not necessary to answer the question, but let me ask you, is this a right Riemann sum or a left Riemann sum? And how do you know? It's a right Riemann sum. How do we know it's a right Riemann sum? Because it does not start with 0. So if it's a right Riemann sum, let me ask you this. What are the bounds? It goes from what to what?
0 to 1.
How do you know it is 0 to 1, Jackson?
Because it ended with 1. It started with the value right over 0.
Okay, so when you say it ended with 1, you're saying that the last value here is 20 over 20, which is 1. And the first value here would be 0 if this were a left Riemann sum. But since this is a right Riemann sum, it starts with the 1 over 20. Okay, so I would agree with that. So the bounds are from 0 to 1 because it begins with 1 over 20 and it goes to 20 over 20. Well, if that's the case, I can eliminate one of the answer choices. Which one? A is out. Why? Because my bounds go from 0 to 20. And I know that the bounds have to be from 0 to 1. Okay? I can also eliminate D. And the reason I'm going to eliminate D is look at the denominator of my function. Is the denominator changing? 20, 20, 20, 20. No, it is not changing. Therefore, my denominator has to be constant. It cannot be a variable, right? So I know that my variable cannot be in the denominator. Okay, well, that leaves C or B. Which one is the right answer? This is the right answer. Okay, and the reason it's the right answer, go back to the first page. Let's go back to the first page. This is the reason that I did the first page. Okay, look, I've got a left Riemann sum. I've got a right Riemann sum with 8 subintervals. I've got a left Riemann sum with 40 subintervals. This right here, the 1 over 10, e to the 0, all the way to that. And then the 1/2 all the way to e to the 4th. These are approximations for what? For this right here, the integral from 0 to 4 of e to the x dx. Okay, the 1 over 20 out front here is just a distractor. Okay, this is not correct. This is just telling you how many rectangles there are, and it's the width of each of the rectangles. So this is the correct answer.
Is there ever going to be a number in front of that?
You're saying in front of the integral on a question like this? I would say probably not. But I would have to, I'm sure. I think the connection that you need to make here is that this Riemann sum approximation is just an approximation for this definite integral from 0 to 1 of x squared dx, okay? And so there is no number out in front of the integral in this case. I hate to say that that would never be the case, okay? But the connection that I want you to make is that this is a distractor here. This is just telling you how wide each rectangle is, okay? And that, it's an approximation of 20 rectangles for the definite integral from 0 to 1 of x squared dx. Okay, well, we have 7 rules that you must know in regard to integrals. So turn the page. All right, common rules for definite integrals. The first rule is the 0 rule, meaning that if I integrate from a to a, the value of that is 0. Why? Why is there no area? Because it's just a line, right? If I'm integrating from 3 to 3, that's just a straight line, and the line has no area. Therefore, the area under the curve must be 0. The next is the reversing limits rule. I have the integral from a to b of f of x dx. That is equal to the negative integral from b to a of f of x dx. So the bounds here are reversed. When we do that, the sign changes. Okay, if I switch the bounds, I have a as my lower bound and b as my upper bound, and here they're reversed. I've got to put a negative out front of the integral. The next rule is the constant multiple rule. That means any constant, let's call it k here, I can take and move it outside my integral and multiply it by the integral. The next rule is the sum rule. The sum rule says if I have the integral from a to b of f of x plus g of x, I can split these up and keep the same bounds. So I have the integral from a to b of f of x dx plus the integral from a to b of g of x dx. And very similar to the sum rule, except we are subtracting, is the difference rule. It also works for a subtraction. So the integral from a to b of f of x minus g of x, I can split those up, keeping the same bounds, and subtract. And finally, here we have the interval addition rule and the interval subtraction rule. So the interval addition rule, if I integrate a single function from a to b, and then I integrate that function from b to c, okay, I can combine those two things together to get my single bounds from a to c. And likewise, it also works for subtracting, okay? So the integral from b to c of a function is equal to the integral from a to c, the whole thing, minus the integral from a to b. So what I want you to do is look at the 3 examples at the bottom and name the rule that is being shown. All right, so I have the integral from 0 to 4 of 5x cubed plus 6x. That's equal to the integral from 0 to 4 of 5x cubed dx plus the integral from 0 to 4 of 6x dx. Which rule is this? It's the sum rule. Next, the integral from 1 to 3 of 4x plus 9 dx plus the integral from 3 to 5 of the same function is equal to the integral from 1 to 5. So this is the interval addition rule. And then lastly, the integral from 1 to 5 of 3x squared dx is equal to the negative integral from 5 to 1 of 3x squared dx. This is the reversing limits rule. So now we need a little practice doing some math. Here we go. Turn the page. And let's put this all together. First, take a little stretch break. Break time is now over. Here we go. So we have a function, h of x. It is a continuous function made up of line segments. And we are going to calculate the following. So the first one, part A, says the integral from -3 to 1 of h of x dx. So I am calculating the area under the curve, which is the area between the function and the x-axis. In this case, from -3 to 1. So this is a triangle. And I know how to find the area of the triangle. It's 1/2 the base times the height. So my base here is going to be 1, 2, 3, 4. My height is 2, which gives me 8 divided by 2. So I know that this is 4. And so what I'm going to do now is do a little bit of the work here. I'm going to go ahead and find these other sections. So the integral from 1 to 4, this is a triangle. This time it's below the x-axis, right? So my base is 3. My height is -2 below the x-axis. So this will have an area of -3. Now I'm going to do from 4 to 5. It's also a triangle. I've got a base of 4, a height of 2. So my area is 1. And the last one here, you can do this a couple of ways. I'm going to go ahead and use the trapezoidal formula area, okay? Which, oh, we did it yesterday, right? It's the height divided by 2 times base 1 plus base 2. So my height is -2. It's below the x-axis. So I've got -2 divided by 2. And my first base is going to be 3. And my next base is 1. So that gives me 4 times -1. So this has an area of -4. And that's going to help me work through some of these integrals, okay? So here we go, B. The integral from 1 to -3 of 4 h of x dx. The first thing I'm going to do is use one of my rules and move the 4 outside. It's a constant. So I can write this as 4 times the integral from 1 to -3 of h of x dx. Now I'm going to use one of my other rules. Which rule am I going to use? Reversing limits. Why the reversing limits? Because my bounds are out of order, right? It goes from 1 to -3. And so I'm going to reverse them. And when I reverse them, it becomes negative. So I've got -4 times the integral from -3 to 1 of h of x dx. And what's the integral from -3 to 1 of h of x dx? I just found it over here. It's 4, right? So that's going to give me the value of the integral is 4. There's a -4 outside the integral multiplied by it. Therefore, the value of this is -16. Okay, part C. The integral from 1 to 5 of h of x dx. So I'm going from 1 to 4 and then from 4 to 5, adding those intervals together. So that's going to give me -3 plus 1. So the value of this is -2. Okay, questions on any of the first 3 that I did there?
On B, why did you have to change the bounds?
I do not have to, on part C?
B.
I changed the bounds because they are out of order, okay? The lower bound is 1 and the upper bound is -3. And since 1 is greater than -3, I always go from lower bound to upper bound. So I reverse them.
The greater one.
-3 to 1.
Okay, so greater one always has to be on top?
Yes, yes. Well, here is my little challenge for you. Why don't you try the next 5 on your own? And let me just throw down a little challenge for you. All right. See what you got. So nobody in first or second period got all 5 correct. I mean, if we were having like a little mini smackdown, right, I would reign victorious yet again, but we're not going to do that. I will challenge you, though, to see if you can show me your calculus skills, right? See if you can get all 5 D through H correct. And obviously, you find people are much better at calculus than my first or second period, so I have high expectations for you. So go, work together, work on these. Let's see what you got. Take a couple of minutes, and then we will come back and check your work. Why don't you collaborate just a little bit longer here? See what you got.
Are you sure they didn't get all 5 of them? You wouldn't split it? I don't know, I just feel like
You're sneaky there, coach.
Nobody's gotten all 5 yet.
Can I get an RFA written on my paper? I get all 5.
You definitely are.
How about we cross that bridge when we come to it?
Okay.
Coach, I'm gonna break the mold. I'm gonna get them all ready. Watch.
I guess we'll see.
Well,
I wrote 2 minutes actually.
So we add all of them. And you get to have all of
Or this one. Yeah, this one. No, you do it first. Yeah, you're right.
All right, well, here we go.
I don't know. Either I'm really smart or I'm really stupid.
All right.
Yeah.
For D, who wants D? Somebody,
I want D.
come on. Show me what you got.
3.
Justify it for me. Why is it 3?
Because 1 to 4. I mean 4 to 1.
We need to reverse it, right? All right. So when we reverse it, we got a negative outside the integral, and the integral from 1 to 4, we found over here, it was -3, and then the -3 makes this +3. All right, we're rolling. E, who wants it?
I got -2.
Tell me how.
I just added up all the values from -6 to 5
Why don't we reverse anything?
because it's from the left.
It's in order, right? From lowest to greatest. So we just, the 4's canceled. So then we got -3 plus 1. Indeed, it is -2. All right. Well, the absolute value one.
I said it's 12.
I said 12 at first, but then I changed.
Okay. Well, what is the integral finding? It's the area under the curve, right, of the graph. And what does the graph of the absolute value of h of x look like?
Oh, okay.
It would take those negative parts and flip them over, right? And then we would calculate the area. So indeed, it is 12. All right. And so here on G, we need to reverse this. So we're going to go negative integral from -6 to -1 of h of x dx. And from -6 to 1, excuse me, -6 to -1, I've got -4, and then I've got half the triangle there. So the area of half the triangle would be +2. All right, so -4 plus 2 gives me -2, but I've got a negative out front. So that makes this +2, which brings us to the last one. All right, yes, Diego. What'd you get?
I have 2 answers. And I'm going to say -3 first.
Way to hedge your bets there, but yes, go ahead.
I'm going to say -3. And if that's wrong, then I'm going to say 4.
Diego, I'm sorry, but both of those answers are wrong.
What?
That's
I
wrong.
got like 18.
We were not taught this.
That's wrong too. We were not taught this. I like that excuse. Well, I beg to differ. So here we go. Let me split it up.
Yeah.
I'm gonna write this as the integral from -6 to 4 of h of x dx plus the integral from -6 to 4 of 7 dx. Can I do that? That's one of my rules, right? What's the value of this from -6 to 4? The -4 and the +4 are going to cancel, making this -3 plus this right here. Okay. What's the value of this? It's not. It's not. Strike 3. Well, hold on. The integral is what? The area under the curve. What's my function? So let's graph it. Horizontal line. Y is equal to 7. Correct?
7.
It goes from -6 to +4.
70.
That gives me a rectangle with an area of 70
You said you can't find the area under a line. You said that earlier.
of a vertical line, Diego, but a horizontal line does have area.
You are one slimy little snake, coach. You know that? You
Hey,
are slimy.
positive 67. You couldn't even get all 5 right.
The anger and the vilification of your teacher over at not getting RTA written on your paper is just hurtful,
I'm
Jackson.
just a little frustrated. Yeah.
All right, well, how about we take out our frustration on the last few problems? Here we go. Let the integral from 1 to 10 of g of x dx equal 5, the integral from 1 to 4 equal -7, and the integral from 4 to 6 equal 9. First, we want to find the integral from 4 to 1. Well, this would just be +7 using my reversing limits rule. Okay. Here I have the integral from 1 to 6. So I'm going to use my interval addition rule. I can split this up as the integral from 1 to 4 plus the integral from 4 to 6. That's going to be equal to the integral from 1 to 6. And the integral from 1 to 4 is -7. The integral from 4 to 6 is 9. Therefore, combining those should get 2. All right. Well, let's look at this one. I have the integral from 6 to 10 of 5 times g of x. So it helps me to think about it, writing it like this. Let's do this. I'm going to say the integral from 1 to 4 plus the integral from 4 to 6 plus the integral from 6 to 10 is equal to the integral from 1 to 10. Right? Yes? That's one of my rules. So what's the integral from 1 to 4? It's -7. What's the integral from 4 to 6? It's 9. Plus the integral from 6 to 10. I'm not sure what that is. I need to find it. And all of that is equal to the integral from 1 to 10, which they tell me is equal to 5. Okay, so this gives me 2 plus something equals 5. Therefore, I know that x is 3. And therefore, the integral from 6 to 10 of g of x dx equals 3. And then I can take my constant and move it out front. So I have 5 times the integral from 6 to 10, which I know is 3. Therefore, this value is 15. All right, and finally, I've got the integral from 6 to 10. I'm going to move the 3 out front, and then I've got g of x dx plus the integral from 6 to 10 of 8 dx, splitting those up and moving the constant out. I just found the integral from 6 to 10. I know that it is 3. So I have 3 times 3, which is 9. And then what's this? How do we know? It's a rectangle that has a width of 4 and a height of 8. Therefore, I have 9 plus 32, which is 41. Well,